Good evening, all of you. Welcome you guys. Welcome you all. Welcome you guys. Welcome you all. I think we are live. So please, can you please confirm is audio video is clear to all of you? Confirm the audio video is clear. Is the audio video is clear to all of you? Tell me all of you. We are live. So welcome to Unacademy. Welcome to Kreatryx. So in this series, we are going to discuss about the most expected questions. We are going to discuss and some of the tough PYQs also we are going to discuss, and we are going to discuss about the networks and digital in this series. We are going to talk about what networks and digital we are going to discuss, and you can follow me in this telegram group. You can search in the telegram group this thing, so you can search in the B.V Reddy GATE. You can follow me, and after completion of the class the complete PDF is available in the telegram channel. And to enroll for this Unacademy, you can use a code of B.V Reddy to get the maximum discount. Use a code of B.V Reddy to get the maximum discount. Right, we are live. Yes. And you can use a code of B.V Reddy to get the maximum discount आपको मिलने वाला. We are starting the new batches. We are starting continuously, and you do follow me in these new batches. So for the networks and digital, we are going to discuss some of the most expected questions. And we have great announcement to all of you. So from the Unacademy team, so you can find the top educators. You can find the single frame here, and you can see. So and the new batches are starting from January 28th onwards. You can have this is a batch C, and so my digital course is also running. So you can do follow the courses and to enroll for this by using a code of BVReady. Once you use a BVReady code and your guidance and preparations will be taken care by the BVReady sir. Now these are the Bunyad batch for the 2025 के लिए. You can find the top educators team you can find, and these are the advantages. So Praveen Kumar, so here I don't know the name of this thing. I think Ankit Goel, I think so. Ankit Goel sir, I think so. Is the Ankit Goel sir, I think so. Not GOEL, so I think. Yeah. Is this series is correct? One second. I think there is a small confusion. I think so. Some students might be joined in the some other link. They might be joined. So might be the students has missed the link. So they received the different link they received. Really sorry for this thing here. The students might be gone to some other link. They might be waiting. You might be received a different link. I think students might be used a different link. Students might be joining in the some other link, I think so. To inform to all your friends, ask them to join with this link. I think the students might be joined some other link, I think so, isn't it? By mistake has shared the some other link have shared. I shared the some other link have shared. So it was mistaken. So here, and do share to all your friends. Ask them to join this link. So just please wait for 2 minutes. So then let the remaining friends then come join. Let the remaining students let them join. Okay. So actually by mistake has shared the some other link has shared in the groups and all. Fine. Chalo, let's continue our discussions. And the other new batches we are starting for the 2024 as well as 2025 now. And these are the key differentiator for this batches. You can see, have a look at here. And there is a price hike is going to happen. So then all of you do enroll for the batches as soon as possible by using the code of B.V Reddy. By using a code of B.V Reddy and do join these classes. Right. Now, so we are coming to fulfill all your dreams in the YouTube as well as a plus stream. So just stay tuned, all of you. And these are the 2022 ESC top rankers. And you can find the mission IRMS batch we can see, and these are the top educators team you can see. Right. And you can plan this gate subscription, gate plus UPSC combo, you can able to plan it. And chalo, let's start our discussion, all of you. Now आज का सेशन में हम डिस्कस करने वाला नेटवर्क्स as well as a digital will do. Networks and digital we are going to do in this session, today's session. So let's start now here. Find the VTH, Thevenin's resistance across the terminals. Now here what we can do here to find the VTH, the Thevenin's resistance RTH, will go for the VT80 method. And before this, what I will do here, we are applying a source transformation for this. Then if I apply the source transformation, how much is current, you tell me now here. This current is a 2.5 milli. 2.5 milli and current का direction ऊपर आई ना, and then this resistor will come to parallel to this resistor. So दोनों मिला के कितना होगा, tell me now here, 1K. Now again source transformation. So then it will becomes what you tell me now, 2.5 volts upper positive, and this is 1K. Now I can redraw the network. From this we can redraw the network. Now tell me. Now this voltage is 2.5 volts, and this is my 1K, and here we can see the dependent voltage source we can find. This is my plus minus, and they given this is my 3Vx, and here this is 1K, and this voltage they given us what you tell me now here, Vx. Now I'm doing the VT-IT method. So here we can connect the VT-IT, then VT, and here this is my IT. And you can see the first observation, we can say Vx and VT both are equal. You can say here Vx which is equal to VT only, right? Now at this node voltage it is the directly VT. Let's apply the nodal equation at the VT node. Tell me now here, VT minus or minus plus 3Vx minus 2.5 by 1K plus VT by is equal to IT. Now let's simplify now here, Vx is equal to VT only now. Let's substitute now here, Vx and VT both are same, so then it will becomes what now here, 4 plus 1 5, that means 5 VT by 1K is equal to how much, you tell me now here, 2.5 by 1K plus IT. Now let's simplify the equation now here. What I will get now here, VT which is equal to, so this is 5 by 2, so then it will becomes what you tell me now here, so 2.5 by 5 plus what we can say here, 1 by 5 into 1 by 5K into IT. You can tell me now VT which is equal to, tell me now here, this is 0.5 plus I can say this as 0.2K into IT. So from this equation we can say the VT and ITs. Now tell me how much is VT, how much the VT value. So from this we can say the VTH which is equal to 0.5 volts, and then RTH which is equal to 0.2 kilo ohms. Can be next. Take the next problem. For the circuit shown in the figure, the Thevenin's voltage and the resistance looking into the terminals X, Y. Thevenin's voltage and Thevenin's resistance. Now, let us do this VT-IT method directly. I am doing the VT and IT. So this is my VT and this current is IT. Now this is single node only now, so that means this total voltage is VT only. Let's write the nodal equations now here. VT minus 2I by 1 plus by 1, and entry current, that is VT by 2, which is given as what I can say 2 plus IT. And here you can see now this I is equal to, tell me now, VT by 1. I equal to VT only. So from this what I can say now here, we will get this Vt is equal to, tell me now here, 2 plus It. Then Vt, which is given as, tell me now here, 4 plus 2 into It. Option D. So we got this VTH value. So VTH value, which is equal to 4 volts, and RTH value, how much here? 2 ohms. Next, for the circuit shown in the figure, Thevenin's voltage and Thevenin's resistance. Right. Now, let's apply the VTIT method. So this is my VT and this current is IT. Right. Now tell me now here, this total node voltage, I can say this is my VT here. So 1, which is equal to nodal equation, tell me now here, Vt by 5, and here It is entry current, plus what we can say now here, I1. So plus I1. I1 is equal to what we can say now here, that is my Vt minus 10 by 5. Tell me now here what I'll get, 2 Vt by 5, which is equal to 2 plus 1, 3, 3 plus It. So from this what I'll get now, Vt, which is equal to what you tell me now, 15 by 2, plus what we'll get now here, 5 by 2 into It. So this tell me now VTH value. VTH value is 7.5, and the RTH value, which is equal to 2.5. Right? Next. Now tell me now here, the value, the maximum power delivered to RL, if its value, that means we need to find the RTH value now for MPT. RL must be equal to RTH only. So then directly we can go now here, I can do the source transformation also here. Let's do the source transformation also. Now this current source will become a voltage source, you tell me, and the current source will become voltage source. And how much this value, tell me now here, which is equal to 10 I1, dependent current source will become dependent voltage source. Right. So we are doing the VTIT. Digital is there after. Digital questions also there after, I can say here, around after half an hour we can start the digital. $50, and this is my 40. This current is given as I1, and here this is my VT, and this is my IT. Yes, now let's simplify this thing here. So now what we can do here, we need to find the RTH value, we should find. Tell me now here what I can do here. This node voltage is a VT. Tell me now here, VT minus 10 I1 by 20 plus Vt minus, I can say this current is given, this current is given as leaving current only. How much this current is a I1, which is equal to, tell me now here, IT. So what we'll get now here, this is my Vt by 20, and this is minus 1 by 2 plus 1. So it is plus 1 by 2 now, plus I1 by 2, plus I1 by 2, which is equal to IT. You can tell me the I1 value. So this I1, which is given as Vt minus 50 by 40. Vt minus 50 by 40. Now let's simplify this thing here. Vt by 20 plus what I can say here, 1 by 80 into, so Vt minus 50. Vt minus 50, which is given as what you tell me now here, It. Now let's simplify now here. Vt we have taken common, so we can say this is 4 plus 1 by 80, and which is equal to, tell me now here, 5 by 8 plus It. So tell me now here, so this value 1 by 16. So here which will get what now here, 10. 10 plus what will get now, 16 into It. You can tell me now here. This what I can say now here, VTH value. So how much the VTH value, 10 volts, and RTH value, how much the RTH value, 16 ohms. So the option A. Next, see this one here. A network has three resistors, 4 inductors, and 5 capacitors. Then the number of resistors, inductors and capacitors in its dual form of the network is, and we need the number of resistors, inductors, capacitors in the dual form. And you can see now here, the network has a 3 resistors. We have a 3 resistors, and it will be, when this is converted to the dual form, the 3 resistors will becomes what now here, 3 conductors hoga na. Next, 4 inductors. We have 4 inductors will becomes what you tell me now here, 4 capacitors. Next, 5 capacitors will becomes what you tell me now here, 5 inductors. So comes the option, tell me now here. So comes the option now here, option B. Isn't it? Next. And so these problems are based upon the reciprocity theorem. And these problems are what? Reciprocity theorem. You can see now here. Now, so by using the network A, we need to find the network B analysis. We have to do it. Fine. सबसे पहले, so I can find the equivalent resistance now here from this. I can say this is my RTH, which is given as what we can say, 10 by 4. Since the network is a reciprocal network, whether you find from source side or load side, RTH value to same aina. Reciprocity theorem, which is applicable only for the reciprocal networks only. Okay. So now the RTH value, which is equal to 5 by 2. Now you see this thing here. So this voltage, we know here, this voltage, it is like open circuit voltage now. Now I can call this is nothing but something VOC or VTH. This voltage, which is nothing but VOC, that is nothing but what you tell me now, VTH only. The VTH, which is equal to 4 volts. Now you tell me now, I can make this as this network. Yeah. Now as we know here, so if one side is a current, other side is a voltage, vice versa we need to have. And here is my network. I made this network, the second network also like a first network only. Next, when we have this current, when we have this is the 4 amperes of current, I can say that this voltage is the open circuit voltage, that is a Thevenin's voltage. How much is value, tell me? How much the Thevenin's voltage, tell me now here, VTH? That VTH value, which is equal to exactly 4 volts. When this 4 amperes and this VTH value 4 volts. But like in either how much we have, 6 now here. So to get the 6 now, I will multiply with 6 and divide with 4. Can you tell me now how much my VTH value here? That is, so if the excitation is multiplied by some constant K, the response is also multiplied by the same constant, right? So this 4 into what I can say now here, 6 by 4. So how much will get the VTH, you tell me now here, which is equal to 6 volts. This is my VTH. VTH we know and RTH value we know. So then what I can do here, this network we can replace it as a Thevenin's model. Thevenin model we can replace now here, and here is a VTH, and what are the load is there, that load will reconnect back here. So how much the RTH value, which is equal to 2.5, and how much the VTH value, tell me, 6 volts. And you can see this value of load resistance, which is equal to how much, you tell me now, 5. So we need the current to this element required now here, this current required. So tell me how much this current now here. So then I, which is equal to what I can say now, is 6 by 7.5 now. So how much will get, you tell me, this current? I think it might be a nearly something 0.8 like this. How much will get this answer? I think so nearest option is this thing. Isn't it? Tell me, 0.8. Here what we used, you see this thing here. Here this problem is based upon the combination of reciprocity theorem. It's a combination of reciprocity plus Thevenin's theorem. Here how we'll get, we need to apply the Thevenin's theorem. How we'll get this idea to apply Thevenin's theorem, since we know this as open circuit voltage. Here we know what we know, open circuit voltage. That's why we need to apply the Thevenin's theorem. And here you can see now in this case what theorem we need to apply. You can see here, this is the this current is given short circuit current, short path now. So we know this current, we know this current is given 2 amps. This is short circuit current. So short circuit current is there in a Norton's theorem. So that's why here we use a Norton's theorem, right? Now as usual, so can I find the RTH value? RTH value, which is given as 20 by 5. This is my RTH. And thereafter, now you see this thing here, if the one side is a voltage, other side is a current, right? Now you can see now here, this other side we know current, so this side must be a voltage, right? So this side is a voltage. That means what we can say now here, if the network is like this, and this is my network, and if this voltage, if this voltage is at 20 volts, and I got to know this current is how much, you tell me, downward direction, this current is at 2 amps, isn't it? Now but here, but this actual, this voltage how much, you tell me here, 30 volts now. So what I need to do here, I will multiply with 30 this voltage and divide with 20. So then ये 30 volts हो जाएगा. That means what is my coefficient, you tell me, K value, 3 by 2. The same thing I need to do here also now. Here 3 by 2 से multiply करना पड़ेगा. If I multiply the excitation by constant, response is also multiplied by same constant. So how much will get my short circuit current, ISC? Now ISC we got this as a 3 amps. We have RTH value. So what I can do, we can form the Norton's model, we can form now, and we do form this as a Norton's model, isn't it? And this Norton's model, and what the load, we can reconnect back this load here. So this is my 3, and here this is my 4, and this is how much, you tell me, 2, right? So I need the current in this branch, I need, now tell me, so this current, so we can apply the CDR. tell me the current division here, which is given as 4 by 6 into 3. So how much we'll get now here, which is equal to 2 amps now? 2 amps. So now you tell me now here मैंने क्या use किया, tell me the. Now in this case we use a concept of reciprocity theorem, reciprocity plus Norton's. So in this case we use a reciprocity and the Norton's theorem हम use किया. चलो. Now let's see the next topic now here, two-port networks. Now let's see the problems on two-port networks. So for the two-port network shown below, the short circuit admittance parameter matrix is short circuit admittance parameter matrix. We need the admittance parameters. So first of all, admittance के लिए the condition is the network must be a pi shape. Network is pi. And the other condition is what you tell me now, units must be mhos. The strictly condition is what you tell me now, units. But the units are mhos होना पड़ेगा. The units must be mhos में होना पड़ेगा. So this is 0.5. Convert into mhos. You tell me now here, which is a 2 mho होना, and this is 2 mho, and this is also 2 mho. Now we can do the admittance parameters. Tell me now admittance parameters. So which is given as 4 minus 2 minus 2 minus 2 and 4. Tell me now here option A. Next, the H parameters of the circuit is, here we need the H parameters. So H parameters के लिए हमको कोई शॉर्ट ट्रिक नहीं है, so इसीलिए हमने नॉर्मली फाइंड आउट करना पड़ेगा. टेल मी द H parameter equations एक बार. V1 is equal to H11 I1 plus H12 V2. Next, I2 equal to H21 I1 plus H22 V2. Now so here options are there, so what we can do here, we can check this thing which is unique manner. So you see this thing here, अगर मैंने, so if I find this thing here, H22 is a unique manner, not H12, I can find H12. H12 which is given as, tell me, V1 by V2 when I1 equal to 0. Instead of finding all the things, we can check the whichever is different, unique, that parameter we can find. Why? Because this is different, this is different, this different, this different. Okay, that's why I am finding the H12. Tell me H12 when I1 equal to 0. So when this I1 value 0, now you tell me now this current is 0. So this current is I2 here. This current is I2. So then this voltage is a 0 volts now, tell me. So you can tell me now this voltage is a V1 and this voltage is also V2. So that means what you tell me now, V1 by V2. So which will becomes 1 now? V1 is equal to V2. So option D. Isn't it? Next, Z matrix. The next one, Z matrix. Now tell me, let's find the Z matrix here. Right. So here this current is a I2. Now this current is a 2V3. This current is a 2V3. That means remaining current will go here. This remaining current, how much here? This is I2 minus 2V3. Right. And then this current is how much here? You can see this is 2V3. Now here this current is I1 plus 2V3. Isn't it? So then this total, this current will becomes what you tell me, I1 plus I2 hoga na, tell me. Now this current is I1 plus I2. Now let's write the KVL in the two loops. So what I can say now here, V1, which is given as I1 minus 3I2 plus what you tell me now here, 2 into I1 plus I2, 2 into I1 plus I2. So then what I can say now, V1, which is given as 2 plus 1, 3, 3I1, and then what now here, 2, so this is minus I2. This is the one standard form of a Z parameter equations. Now second loop, apply the KVL. So then V2, which is given as 2 into I2 minus 2V3, I2 minus 2V3 plus V3. And here what is a V3 is given as, tell me, 2 into I1 plus I2, 2 into I1 plus I2. So tell me the V2 value here. So means this is 2I2. So this is minus 4 plus 3 plus 1. So it is minus 3 into so this 2. So that is 6 hoga now here. Finally, which will become 6 into I1 plus I2. So then what I can say now, V2, which is given as 2I2 minus 6I1 minus 6I2. So yeah, tell me now V2 value what I'll get here, minus 6I1 minus 4I2. All of you tell me. These are standard Z parameter equations you see. So the Z parameters which are given as 3 minus 1 minus 6 minus 4. Done everybody? Hello, next problem. Now see the another problem here. The ABCD matrix they given. The ABCD parameters they ask you to find. Tell me the ABCD parameters now here. I can divide this into your two networks. We can divide a cascading form of a two networks. Right. Now, so if I call this is a network, this is the B network. Let us find the TA and TB. Let us find the T and TB. So TA which is given as, tell me now, 1 plus ZA by ZB. So that is 2 by 5. Next what we can say, ZA. So this is 2. That is 1 by 5 and this is 1. And what about TB, tell me here, which is given as 1 plus ZA by ZB. So this is ZA and 0 and this is 1. Right, so from this overall T matrix which is given as, what I can say here, 7 by 5 and 2, 1 by 5 and 1 into, tell me now here, 1 2 0 1. Here they are asking to find the B parameters, so we can multiply now here this rows with this column. So what I'll get, you tell me now here, 7 by 5 plus 0. Now this is 10 by 5 plus 2. Next 1 by 5 plus 0. 2 by 5 plus 1. Now simply if I see here, what I'll get now here, this value. We need B now here. B means only this thing. So this means what you tell me now here, 10, 10. So here 10 plus, so this is directly 4 now here. How much this value? This value required, isn't it? So how much, this is the B value now here. So B is equal to how much here? 4. Yeah. Oh yeah. See the multiplications. So this multiplied by this thing now. Here this is how much this value? How much this value? Isn't it? गलत किया क्या? So here 7 by, yeah, this is 14 by 5 plus 2 now. Check it all of you. 14 by 5 plus. Okay, so then it will be, yeah, so then B value, how much you tell me now here? So this is 14 by 5 plus 2. So how much is value? 4.8. Check it. Next one. The equivalent impedance seen across X and Y is. Now they are asking to find the equivalent impedance seen across the terminals X and Y. I will extend this thing. This is my X, this is my Y. So I need the X and Y equivalent impedance is required. So here what I can do here, now I can say this as the equivalent impedance between X and Y, RXY, which is given as, tell me what I can say now here, the voltage V by current I can say now here. So let us call this voltage here, this voltage which is equal to V, and this current which is coming from the X to Y, the current which is going, that is X to Y, that is I current. Now if you see carefully, now here this current, some current will go here, some other current will go here, isn't it? Now this current I am calling this thing as a Ix, and this current I am taking this thing as a Iy. The total current I is given as, which is given as what I can say now, V by I, which is given as Ix plus Iy. V by Ix plus Iy. Now let us see the relations now here. Since we know ABCD parameters, let's write the equations now here. Basically we know this voltage which is equal to V1 and this current is I1, right? This voltage V here and this current is Ix. If I know the parameters, we can write the ABCD parameters of equations now here. That means here V2 means V is equal to V1 is equal to, how we can write the ABCD parameters remembered? Basically, so here V1 which is equal to AV2 minus BI2. These are standard form of ABCD parameter equations now, tell me. Next, I1 equal to CV2 minus DI2. CV2 minus DI2. Right. Now here V1 is V1 is equal to AV2. V2 means what you tell me now, V only. V2 minus BI2. I2 means what you tell me now, Ix here. Next, I1 equal to, so here CV2 minus DI2. These are the equations you tell me. Now you can see now here, since this C shorted this thing here, so how much is V1 value? V1 value to 0 होगा. Since it is shorted, this V1 value 0 हो जाएगा. So from this equation I can get the value of Ix. Can you tell me the Ix value here? Which is given as A by B into V. Now let us get the Iy value also. So for this we use the second equations. Now tell me for the second network equations we can write. Tell me now here. So V and this voltage which is equal to V2 and this current is a I2, isn't it? Now you see this thing, this path which is what now here, which is open now, tell me 0. Tell me now equations what we can write now. V is equal to V1 is equal to AV2 minus BI2. So B into I2 value to 0 आई ना. Next Iy which is given as, tell me now here, CV2 minus DI2. I2 value to 0 I. So from this I can say now here Iy. So we got this thing here, V2 value. Here V2 value which is given as, tell me now here, Iy by C. V2 value if I replace in this first equation, then I can get V is equal to, that is A by C into Iy. So from this I can say now Iy which is given as C by A into V. This is my Iy and this is my Ix. So finally, so what I can say, my resistance, you tell me now here, Rxy which is given as V by Ix plus Iy. Ix is how much, you tell me now here, A by B into V, and Iy value how much, you tell me now here, C by A into V. V will get cancelled. So tell me now LCM which will be A. AB will come. So that means AB by, tell me now here, A square plus BC will come now. So this is my RXY. So option A. Is it fine, all of you? Tell me. Check the next problem. The jet parameters or the network shown in the figure are, they given the jet parameters, they ask him to find the average power delivered to the load resistor RL. We need to find the average power. Now to find the power across the load resistor, we should find what you tell me now here, VTH and RTH we can find. From that we can find the values of power. Here they ask him to find the average power, not the maximum power, remember. So for maximum power, RL must be a variable, but here RL is constant now. Here it is average power, not the maximum power. And you can see now here, let's see. Since I know the Z parameter equation, can I write the equations here? First of all, V1 which is given as, what we can say here, Z11 I1 plus Z12 I2, 60 I2. Next V2 which is given as Z21 I1 plus Z22 I2. These are the V1 equations we got. Right. Now I want to find the VTH and RTH. So we'll go for the VTIT method. Tell me. So I have connected my VT here. Remove the load, and this is my IT. So here from this observation, what I can say, this I2 and IT both are equal. And what else now here, V2 which is equal to VT, both are equal. Now so I can replace this equation now here. So that means VT which is equal to 80 I1 plus what I can say here, 100 I2. I2 equal to what you tell me now here, IT only. Now you see this thing, I1 has to eliminate. So let's see how we can eliminate this I1 value from this equation if you see carefully. Now what I can, if I write the KVL now here, so which is given as 20 which is equal to 10 I1 plus V1. That means what we can write now here, so I can replace this equation here. So I can do eliminate this thing here, this V1. So which is equal to 20 is equal to 10 I1 plus V1 value which is given as 40 I1 plus 60 I2. That means from this you tell me now here, 20 which is equal to 40. So this is 50. How much we have? This is my 50 I1 plus 60 I2. I2 is nothing but IT only na. So 0 will get cancelled. I can say from this IT value I can get this 6 IT, which is equal to what I can say here, 2 minus 5 I1. Sorry, we should replace other manner na? So from this we can say this I1 value. So this is I1 value, which is given as, tell me here, 1 by 5 into 20 minus, sorry, 2 minus 0 cancel na here. So this is 2 minus 6 IT. Check it all of you. So now I can replace now VT, which is given as, so this is 80 by 5 16, 16 into 2 32, 32 minus, so here, so this is 16 into 6 IT plus 100 IT. Tell me everybody. So from this what I can say now, VT, which is given as 32 minus plus IT we have taken common. So how much will get now here? This is 100 minus, so 96 now here. So that means VT value, which is equal to 32 plus 4 IT. Check it everybody. This is my, we got the relation. So from this I can write the value of VTH value. So tell me the VTH value from this equation. We got the VTH value is a 32 and RTH value we got this as a 4. Now I know the VTH value and RTH value, and the load resistance value given as how much, you see this thing, 20. Load is given 20, so that means we can form a Thevenin network. Now tell me here, Thevenin's network. So we got the VTH value and the RTH value, and let us, this value which we got this as a 4, and this is 32, and this value 20 given now. So tell me now here this current. So how much is current I value, tell me in the loop. I, which is given as 32 by 24. This current we got. The resistance is 20 only na? Yes. So that means now here, so 3's now here 4. That is my 4 by 3 amps. So the power which is given as, what we can say now, average power I square into RL. That power which is given as now 16 by 9 into 20. So how much will get? Yes, that is only the average power now, I square into RL. So we'll get this value. So that is 35.5 watts. So see this problem. This problem connected with the Thevenin's theorem and the two-port networks. Next, a two-port a two-port network is represented by ABCD parameters as like this. Now the port 2 is terminated by a load of RL. The input impedance seen at the port 1 is, right. Now what they are saying is and this is my network. Now this port 1 and port 2, and this port 2 is terminated by a load. You can see now this port 2 which is terminated by some load of RL. Now they are asking to find the input impedance. This impedance we need to get now here. As we know, this voltage is a V1 and this current is a I1, and this voltage is a V2 and this current is a I2, isn't it? Input impedance seen from the terminals port 1, which is given as, what I can say now, this is V1 by I1. V1 by I1. Now you can see this current now here, this is a current is I2. So from this I can say my V2 which is given as minus RL into I2 now here, minus RL into I2. So what is the V1 value according to the equations? V1 is equal to AV2 minus BI2. AV2 minus BI2 by CV2 minus DI2. DI2. Now, so from this we can replace now here. V2 is equal to what you tell me now here? Minus RL into I2 minus RL I2 into A minus B into I2 by C into what you tell me? Minus RL I2 C minus D into I2. I can say I2 will get cancelled, minus will get cancelled. So finally what I'll get my here? Tell me R value. So which will get this as? Now there, this is a resistance now here. This is my load resistance and this port 2 current is I2, right? The current is I2. Now we should take this second port voltage is V2. So that means how much is V2 value here? Minus I2 into RL. Minus I2 into RL. Now tell me now what will get now here? I2 will get cancelled, that is ARL plus B by, tell me now here, CRL plus D. So कौन सा option tell me? Option B. बोलिए. Done? चलो. Next. Now onwards we'll see the digital problems. Digital. Now see the things now here. The expression for y is, they has given this off adder, some given as off adder. You can see, tell me now here, the output y which is given as, you can see this is S1 bar S0 bar into C plus S1 bar S0 into C plus S1 S0 bar into C bar plus S1 S0 into C bar. So by combining the first two terms, now by combining these two here and by combining these two here, so tell me what I'll get here. That is S1 bar into C plus S0 bar. So what I will get now here? Yes, sorry. This is S1 into C bar. So from this what I can say, this is nothing but S1 XR with C. What the S1 tell me? Sum. Sum means what you tell me now? A XR B now here. So finally the logic expression, so Y which is given as A XR B and XR with C. As we know, XR gate will follows associative law. Why to go for the K map here? K map is lengthy hoga. So then, so you can see now by looking at the expression itself, we can see now. This is directly we can able to simplify by using Boolean algebra. No need to go for K map. K map का जरूरत भी नहीं है. If it is difficult expression, then only we'll go for K map. It's a simple expression only now, so we'll go for the basic method. Now you see this thing here. Consider I think it is, this complete problem is visible to all of you. You can see. Right, we need to identify this is for what cases What you tell me now here? Yes, now which of the following binary input combination does not make the LED to turn on? LED should be off. LED should not turn on. So for what cases we need to get it now here? And tell me now here, LED to be should not be on. That means we need to have output must be 0 होना पड़ेगा. अगर ये output 0 है तो then LED should not get turned on. Yes. Now let's see the first one. Let us see verify the options now here better. You can see this is 110. So you see this thing here 110. So you tell me now here. So here is A B C given now here. So this is A B C. LED नहीं दिख रहा आपको क्या? See, LED is at the output location. Here the LED is connected. Yes. So it is not visible now properly. ठीक है, so ये problem हम बाद में करेगा. So here and tomorrow we'll do this thing here. I will compress the problem and we'll do it tomorrow. Then this is not visible properly for you. Complete today. Let's take the next problem. A 4-bit parallel binary adder is built using 4 adders. Okay, if each adder takes a time of takes 44 nanoseconds for sum के लिए कितना है, sum के लिए delay कितना, so sum के लिए 44 nanoseconds and the carry के लिए how much you tell me? For the carry के लिए, so that is 40 nanoseconds. Now we need to then the time required for addition of a two 4-bit numbers. Now we need to here tell me now here total delay. Tell me the delay now here in case of parallel adder, ripple carry adder, which is given as n minus 1 into what you tell me? TPD of carry. TPD of carry plus max of sum comma carry. ये फार्मूला आपको स्मरण है कि नहीं? ये फार्मूला आपको स्मरण है ना? How many bits? 4 bits. So that is 3 into what I can say carry delay is 14 and max of sum comma carry, and so sum delay is maximum compared to carry delay. So you tell me now here. So this means 52 plus what now here? 44. So how much is value tell me here? Sorry. That means how much now? 86 na? 86 nanoseconds. Yeah, so that is not covered now, so don't worry. So the frequency response analysis. In control systems, we didn't cover the topic, right? So we don't have time, so that's why we didn't not able to continue that class that time. And take the next one. Consider the 4 by 1 mux. So this mux, which is given as E and B, are the two periodic signals with duty cycles 25 and 50% respectively. Okay. Now you tell me now here they are asking to find the average power dissipated by the resistor is. Let's find out the average power dissipated. Now first of all you tell me the logic expression for this thing here output. Now here this output, so you can see the min terms are 1, 2 are the min terms. You can see now here directly. Here they given this is A and this is B given, isn't it? सही है ना? See the connections now here what they given. So this value given, this is A given and this is B given. Okay. Yeah, tell me the logic expression. Tell me now here, which is given as A bar B bar into 0 plus what you tell me now here, A bar B into B and A B bar into A. So then this is 0 now here. So the logic expression which is given as, tell me now here, A XOR B. The logic expression what we got, it is a, which is nothing but A XOR B. Now let us find out this one XOR. Let us find out this output now here. So for this corresponding here, what could be the output, you tell me? When the output of this XOR gate is 1, when both inputs are different, then only output is 1. Right. So now in this case my output, so which is 0 here up to here. Yes, up to here which is 0. Now this output is 1 from here to here only, this output is 1, right? And thereafter which is 0 completely here. And you see this thing here, this part. Yes, in this part, this is how much duration this my output is 1, you see. How much duration my output is 1, that is T by 4. T by 4 duration only output. This duration is how much here? Only T by 4. This is my Y. So from this we can find the duty cycle. So from this we can find the duty cycle, which is given as, tell me now, T on by T total. T on by T total. So which is equal to how much, I can say 1 by 4. The duty cycle is how much here? 1 by 4. Right. Now we can find this as average. So we need power. The power which is given as, tell me now here, which is given as VRMS square by R. So tell me the VRMS value, tell me, which is given as square root of, tell me, that is V on square into D2 cycle plus what you tell me now here, V of square into 1 minus duty cycle. Why 1 by 2, yeah? So this thing, this is how much here, tell me? This is T by 2. So you tell me now this is T by 4. That means this should be also T by 4 only, na? Yes, this value T by 2 means what now? यहाँ से यहाँ तक this is T by 4 and this is T by 4 and this is T by 2. Isn't it? This is another T by 2. T by 2 कैसा? T by 4 ना? Now you tell me now here VRMS, which is given as V on value given as 20 to 5 now here by 1 by 4 and the off value to 0i. So how much will get, you tell me now here, which is equal to, so this is 5 by 2. Now the power, so tell me the power P, which is given as VRMS square, this value how much it is now? 2.5. Means what we can say, 6.25 by resistance value how much? 1K. So this is 1K. So this means what I can say now here, 6.25 milliwatts. So 6.25 milliwatts. Done. Chalo. Next one. Take the next problem. Consider the circuit given below. The output of each converter is given to the adder, which adds them considering the decimal numbers. Okay, the output of the adder is fine. Now, so they given something, they given yes, the numbers, and these are passed to hexadecimal to basics converter. And this number, so that means this number, this must be a hexadecimal में होगा, right? And this number, so base 10 में होगा ना, base 10 to 6, and this number which is a base 8, right? So then all these values are converted to base 6, and this will be added as a base 10. It will do adds them by considering as a decimal numbers only. This adder will do the decimal addition can do. Now let's see here what I can do here. EC, and this is in what system, you tell me now? Hexadecimal. So which we need to convert into base 6. So first of all what I can do, will convert into base 10, will convert now here. We can do this as no. So base 6, this is what now? This is a base 6 converter now. So here when base 6 converter will use the output is in the base 6 mein hoga, right? Now tell me now here, so as we know here, so A, B, C, D, E and F, that is 10, 11, 12, 13, 14 and 15, right? So this E value, how much you tell me now? 14, 14 into 16 plus, isn't it, all of you tell me? And plus C value how much here, which is equal to 12. So this is in base 10 now here. So how much this value, tell me? 14 into 16. How much this value, tell me now, which is nothing but what you tell me? 236 now here. 236 in base 6. Base 10, sorry, base 10. Now I need to convert into base 6 में convert करना पड़ेगा. So let's convert into base. न्यूज आई ही, IRMS को रिमूव कर दिया दिया क्या ये ट्रू है? आप कहाँ से मिला ये न्यूज़? ये न्यूज़ आपको आपको कहाँ से मिला? Here how much is value base 6 में क्या होगा? So 6 3s, now here how much now here? 18. So here how much बचा now here, tell me? 5 into 6 56. Now here how much now here? So here, so what is base 2? All of you tell me. So then here this is my 6 6, and which is equal to 3. Tell me. Okay, YouTube पे आया, कुछ नहीं किया. So here, no. So actually we are in the class now. Here we don't have any information. We are in the class now. We don't have any information. Okay, might be here. Yeah, कभी time. So here just we cannot confirm this thing here. So कभी time. So then viewership के लिए so कुछ fake भी करने वाला अभी तो. You might know about the scenario right now. And this is now base. Okay, so fine. Maybe let's see. Let us confirm. We cannot say this thing. Yeah, he's saying that. He's saying now the new notification came. Let's see. Let's wait for tomorrow. Tomorrow will let us confirm it tomorrow. We cannot confirm right now, so we'll see it tomorrow whether it is सही की गलत है. Don't worry. Now so 20 को base 6 convert करो here. So 3s. So this is 2. Okay, so that means how much you tell me now, this value which is equal to 1032, tell me. This is 1032, and this value how much now, 32 base 6 May, and the 15. So this 15 second, yeah, so 15, this is in what system you tell me now here, base 8 May I. This 15 which is a base 8, so first we need to convert into what now, base 10 में convert करना पड़ेगा base 8, so which is given as 8 plus 5, which means 13, tell me. So 13 को हमने base 6 में convert करना पड़ेगा, so this 6 2 1, so 2 1, check it all of you, this value, all these are now basics, all these are in basics, right? Now you tell me now, all these values inputs are given to the adder. That adder is a base 10 adder. That adder is a base 10 adder. So then it is a base 10 adder. What it will do here? It doesn't see whether this numbers base 6 में होगा, base 2 में होगा, base 12 में so होगा. It doesn't, simply it will do the base 10 addition will do. Nice. So here this thing they have, that's why they has mentioned the output of each converter is given to adder, which adds them by considering decimal number. Okay. So this is the adder na. This adder doesn't see आपने inputs को क्या दिया, whether आपने base, so here base 2 में दिया, base hexadecimal में दिया, so some other base में दिया, it doesn't see. ये केवल केवल क्या करेगा, so here simply do the addition base 10 में करेगा, will give the values. Okay, it will, the addition must be base 10 में करना पड़ेगा. So tell me now here 1032 base 10 addition we should do 32, and this is 21. So which is equal to 5, and this is 6801. So how much this value, tell me? 1085. Done. So like best example is your calculator. Yes, now you can see now here, let us say you have given the number to this calculators, you have given to the inputs the calculators, let us say some other base you have given, you did this as a 2 plus 2, yes, you have given this number, now here 2 plus 3 you have given, let us say 2 is in the base 4 system and 3 is in the base 5 system, let us, you have considered, you have given, but the thing is your calculator will work only for the base 10 system में काम करेगा, it doesn't see whether it is a base 2 में आए, base 4 में, it doesn't see, isn't it? Here this is the one tricky thing. Yes, exactly, right. Take this thing here, consider the logic circuit given below. The minimized expression for f is, minimized expression for f is, now you tell me now here the output expressions. Now here you can see now here this is a LSB, this is the MSB, fine. Now you tell me now this value something we have, this input कुछ भी होगा, so this value which is equal to A naught, we need to find out this value. Can you tell me the F क्या होगा, tell me, this is a decoder ना, tell me decoder, इधर output क्या मिलेगा, tell me now here, A1 bar and A naught bar, yes sir, this is min term na. So this one he is, tell me now here, which is A1 bar and this is A naught, all of you. Yeah, so here everyone is commenting the same thing, might be the, maybe true, maybe, let's see. So can you tell me the what is f value, tell me? So this is A1 bar, A naught bar, plus what you tell me now here, A1 bar and this is A naught. So tell me now f is given as the A1 bar मिलेगा ना, बोलिए, f is equal to A1 bar, A1 bar, so this A1 is given as, tell me A1 को क्या दिया, which is equal to C दिया ना, so that's why f is given as what we can say now, tell me C bar. तो देखो ये प्रॉब्लम देखने के लिए बहुत टफ लग रहा. See this thing here. If you see the problem overall, it is like a very tough thing. But लेकिन इतना सोच बहुत आसान प्रॉब्लम है, isn't it? कभी कभी टाइम प्रॉब्लम्स are like this. Next, the logic function f is equal to a b c d implemented by the circuit shown below is. Now tell me. So now here we'll get this thing here. This is my enable bar. So how much is enable bar? You tell me now here. The output of the NAND gate now, that is a D bar. So that means enable, which is equal to D. So that means enable equal to what you tell me now? D. Right. Now here the min terms, you see this thing here. This is my M0 and this is M1 and this is M5 and this is M7. So these are max terms will come now. Sorry. So what will come now? All these will come min terms or max terms will come. Max terms will come M0 and this is M2 and this is M5 and this is M7. Now you tell me now this output expression here. F is given as what I can say, tell me now here, M0, that is M2, M5 and this is M7, whole bar not NAND gate. So then the whole bar into this working, which is enable. Enable is there now. So that means F is equal to what will come now, this complement of this max term, De Morgan's law. This is M0 plus M2 plus M5 plus, so this is M7 bar into what you tell me now here, enable. So finally F is given as what I can say, this is now complement of max term will use min term now. So this is M0, M2, M5 and this is M7 by enable. So tell me now F, which is given as M0 means what you tell me now here, A bar, B bar, C bar. M2 means A bar, B, C bar. M5 means A, B bar, C. M7 means A, B, C. Into enable means D na. Let's, if I combine these two here and these two if we combine, tell me what I will get. So I will get this as A bar, C bar. Plus this is my AC into D. So which is given as, tell me now here, A x naught C into D होगा option D. Done. Next one. SOP form is given. So here simply, yeah, we can do this thing here. This is what you tell me na, bubble. NAND gate na, NAND gate is equal to the bubbled OR gate. So we can replace OR gate, then bubbles, all the bubbles will get cancelled. We can replace it as a simply OR gate. OB we can do it. And now you tell me now this expression here, can you tell me the SOP form? We need to get POS form. So what are the min terms you tell me? 0, 2 and then 3. So sorry, 4 min terms. This is 4. These are the min terms now here. Now what are the max terms, you tell me? So what are the max terms here? 1, 2, 3, 4, 5, 6, 7. Yeah, tell me the expression now then. So then F, which is given as 1, means what we can say now here? A bar plus B bar plus C. 3 means what you tell me now here? Yeah, so which is equal to A bar plus B. Okay. Max terms now here. So you can verify from the options, so we can verify it now. 1. So you tell me now here. So this max term now. So this is 0, 0, 1. So 0, 1, 1. So 1, 0, 1. 1, 1, 0. 1, 1, 1. So you can verify this thing here. 1. This is 1. This is 3. This is 5, 6 and 7. So option C, tell me. Next. The circuit shown in the figure realizes the function. Yeah. Expressions. This is A, B, C, D and E. Okay. Think this is might be missing. Now you tell me now here what I will get this output here. This is A plus B bar and this is A plus B bar plus C whole bar. So that means it will becomes A plus B into C bar. And here D plus E bar and D plus E hoga either. Now if I say this may output Y, tell me here what I will get. A plus B into C bar plus D plus E whole bar. Yeah, बोलिए now here. So what I will get now, this is A plus B into C, yes, into D plus E whole bar. So tell me now why what I will get here. A plus B bar plus C into what we can say now here, D bar into E bar. Yes, tell me option D. Next. Yes. Now switching circuit. Now tell me now what I will get now here. So this expression Y, if I say, which is given as A into B plus C bar. A into B plus C bar plus, tell me now here, A bar into B plus what I can say now, this is A plus B bar into C. And let's minimize it now here. So which is given as AB plus AC bar plus A bar B plus AC plus B bar C. So if I combine these two here, we'll get this thing as a B. And by combining these two here, we'll get this as a plus what now here, B bar C. Mingle property here. So what I'll get now here, A plus B plus C. So क्या option tell me now here? Done. Now A, B, C, D are the input bits and Y is the output bit in the XOR gate figure. Which are the following statements about the sum of A, B, C, D and Y is correct? Yes, now if you see carefully the Y is given as, tell me now here, A XOR B and XOR with C, XOR with D. SR now tell me. This is the expression. As we know, XOR gate will obey the associative property. Now they given this is y is the output of A, B, C, D. Yes, the sum S is given as what you tell me now, all these terms. So that means now you can just see this thing here, the inputs we have A, B, C, D, and for this we'll get the output now here y, and then sum, and the sum is what you tell me now here, sum S is given as, tell me, A plus B plus C plus D plus Y. See this thing they given, and try to understand this problem here. Now let us consider here the inputs are, so all the inputs are 0, 0, 0. Tell me when the output of XOR gate is 1 for odd number of ones. We don't have any odd number of ones now here, so output is 0. And can you tell me the sum what I'll get here? So 0 plus 0 plus 0 plus 0 plus 0 plus 0. So which is equal to 0 now? Let us consider my input might be of the form, so 0, 0, 0, 1 or 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0. In this set, in these cases, in all these cases, what is my output? Y value will becomes 1, you see. All these cases, my Y value will becomes 1. Yes or no? So can you tell me the sum here? All the cases sum is 1 plus 1. So it will become 2. So this is sum of A, B, C, D. Now here sum of these terms, sum of this sum is 2, not 1. So here this is 1 plus 1 is how much? Tell me, 2. Yes, this is the normal sum, not the digital sum. Okay. Next, if I have taken this as two zeros, we have taken two ones and two zeros. If you have taken 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0. Like this, we have taken 1, 1, 0, 0. In this type of cases, we have taken, if you see carefully, क्या होगा? Tell me, two zeros we have taken. Output y value will become 0 होगा ना? And whatever sum you tell me, if I add this thing here, sum will become 2 na? Yes. Next case, let us take this as a, so 3 ones we have taken. 3 ones we have taken. What is my output to tell me in these combinations? In this combination, y value will becomes what? Y value 1 hoga. Here we have already 3 ones are there plus 1. So yes, sum will becomes 4 hoga. Sum will become 4. Hana boliye. Yes, now let us say here we have taken this as a, all ones we have taken, 4 ones we have taken. Then tell me, so the output will becomes what you tell me now? 0. Output is 0. Whatever sum you tell me now, sum will becomes what you tell me now? 4. You see this thing, sum in all the cases of sum which is always even only now, tell me. Right. So can you tell me the option here? So from this what we can say now here, the sum yes is either 0 or even number. Either 0 or even number. Tell me the next one. The simplified Boolean expression. The simplified Boolean expression for the K-map is given. And what's the minimized form of this thing? Tell me. Here what I can say now, this is A bar B bar. And this is A bar B. So this is A B bar. So C bar D bar. C bar D. C D. C D bar. You can tell me now grouping. So now here I can do this as this quad I can do here. So what I will get now by doing this quad, which I will get this as A bar and C bar. Next, what else I can do here? Yes, any other quad is possible. I can do this thing and this thing. I can do this quad I can do. Tell me now what I will get here. So this is now A bar D bar milega. And I can do this pair. So tell me now here which is A B C मिलेगा. So कौन सा option? Tell me now option A. Yes, this is A B C. Next, and take the next problem. A finite state machine is implemented using D flip-flop. This is the FSM they has implemented using D flip-flops. Okay, and the logic gate shown in the figure. The four possible states they given we have, and Xin is held at a constant logic level throughout the operation of FSM. When FSM is initialized, QA, QB initial values are 0, 0 and clocked. After few clocks, it starts cycling through. So this FSM, which is nothing but simply sequential circuit only. This is the synchronous sequential circuits. So you can see now this user D flip flops, right? Now tell me now here DA. What is the input coming to DA? Tell me here, which is QA XR with QB. Tell me here, all of you. Next, what about DB? Tell me. Second flip flop DB, which is given as X in into QA NAND gate. Now we can say this is, yes, now QA and this QB, these two are the outputs. Just form a table. Initial values given 0, zeros, right? Now you tell me now here again. So we need to verify what will be the x value. X value is fixed now. It may be 0 hoga, maybe 1 hoga. Let us consider here x value we have taken as 1. Consider. अगर x को 1 मान लिया तो so tell me now here QA QB this value 0. If this value is 0, tell me what happened. Let us say x value we have taken 0 have taken. If you have taken 0, this will be 1. So this value 0 D flip flop now here. So this value 1. So x value 0 means 1. So this is 1 1. Next. So this value 0, this value 1. So what I will get now here 0 1. So this value which is 1, this is 1. What I am getting now here 1 1. If you see carefully, the system which is always there here, it is showing only 0 1 and 0 1 only showing. So how many states you see this thing carefully? How many states are there? We have only, when x value equal to 0, we have only 2 of the 4 possible states when x is equal to 0. When x value is 0, here my FSM which is in the only 2 states only gumming. It is happening only for 2 states only. Right? Next, take this problem. State transition diagram for the logic circuit is shown in figure. Okay. Now they're asking, tell me here what we can do. The state transition table. So here let us say this is my A and this is my Q and this is my Q plus. Let's see the working here. When A value is 0, Q value may be 0, may be 1. A value 0, this Q value 1, and 1 0 and 1 1. Okay. Let us see this thing here. When A value 0 we have taken, and let us say Q is equal to 0 we have taken. Q is 0, Q bar is 1. This is the multiplexer, now tell me. This is multiplexer. When X value 0, whichever is connected to X naught, that will come as output now here. So what is my output will come, you tell me? Y value. So here Y, so which will get this as what you tell me? 1 will come. That 1 will come to here. 1 will come to here. Then what I will get the output, you tell me now here? 1 आएगा D flip flop ना. D flip flop. Input is 1, so output will be 1 आएगा. हाँ ना बोलिए. Next, when I given X value, A value 0 and Q value is 1. So if this Q value 1, this is 1, mean this value 0. If this 0 means 0 will come as output, and here this is 0. What is this output will become now 0 now, tell me? 0 आएगा. Next, when A value is 1, so when A value made it as 1, see what happened? If A value 1 and the Q value 0, if I did, is 1. Tell me now, A value 1 means this is selection takes place now. So this output is 0 will come. If 0 will come to here, now this my output will becomes what now? 0. Right. If A value 1, so if I call this as a Q value, initial value, if it is a, so if I say this is 1, this is 0. So tell me 1 means 1 will come. Here this is 1, output is 1. Now tell me now which is a logic now, tell me. So you can see, so here this is my, so 0, and here this is my 1. You see this thing here, 0 to 0, 0 to 1 transition. When it is happening, tell me. 0 to 1, when it is happening, tell me, when A is equal to 0, isn't it? Now 1 to 0, when it is happening, tell me. 1 to 0, when A is equal to 0. Next, 0 to 0, when the 0 to 0 transition you see, when A is equal to 0. And 1 to 1, 1 to 1 here now, when A is equal to, tell me now, 1. So tell me the कौन सा option here? Yes, 0 to 0. When it is now, when A value 0. Yeah, this is A is 1, no? So this is A is 1. कौन सा option? Option D. Okay. Option D is सही ना? Tell me. Which one of the following statement is true about the digital circuit shown in the figure? So this circuit, so we can see now here. Now if I call this is my A and this is a B, this is a C we can call, let us say. Now I can simply indicate this thing as a block diagram manner, we can say now, tell me. And here this is my A, B, C. And you can see now here this is connected. And this is connected to, yeah, shift register. We can treat as like this now, tell me. Now you tell me now here, initially it is 0 consider karo. So now tell me now here clock, and this is my A, B, C. and let's see the working here. When we don't apply any clocks, initially we can consider this as a zeros, 0 0, reset completely. First clock, tell me here, which is a NAND for the B and C. NAND for the B and C, we have a NAND. Tell me we'll get 1 0 0. And the second clock, tell me what happens now here, BC, so 1 1 0. Next third clock, what happens now here, what will get now here, 1 1, so it is 1. Next fourth clock, tell me what happened here, we'll get this as 0 1 1. And the fifth clock, tell me here what happened, we'll get 0 0 1. And the sixth clock, it will be 1 0 0 hoga na. Now you see this thing here, the state is repeated or not, you see. So this state, so repeated, now tell me. Now if I call this state, is my T1 and this state is T2, can you tell me the mod number? Can you tell me the mod number now? Which is given as T2 minus T1. So which is equal to how much, you tell me now here, 5. So it will behave like what you tell me now, mod 5 counter. Next, the large circuit shown, the NAND gate has non-zero delay. Non-zero but unequal propagation delays are there. Okay, the present input condition is given as PQ value given as 0 0. So means if the input condition is changes simultaneously, PQ is given as 1 1, they ask him to find the X and Y values. Okay, so this has an unequal propagation delay. Let us say initially this is 2, this is 4 we are considering. Now tell me initially this P value how much we have taken, 0, and Q is equal to 0. You see this thing, this is a NAND gate. If the NAND gate, one of the input is 0, output will becomes 1. So this gate delay is small, so this will respond fastly now here. This is 1, this 1 will come here, so this value will becomes 1. And thereafter what they did, you tell me now here, they changed the input, they changed now, tell me. They changed the input to what you tell me now here, so which is 1 1 they changed. Tell me now when it is 1 1 kya hone wala, you tell me. When this is 1 1, see what happens now, this is 1 and this is 1. So this gate will respond first. So this value 0 hoga and the 0 will come here, then this value will becomes 1. So that means X value 0 and Y value becoming 1. Isn't it? So this case. Now another case, you see this thing, unequal delays, they are saying which delay is more, they didn't mention now. Let us say this delay is 4, this delay is 2. Now tell me when this value 0, this value 0, this will respond first, this value is 1. If this value 1, so then this value is also 1. Now they change the input, they change it now, tell me. So what the inputs they made, you tell me now here. This is 1, this is 1. So this feedback value is 1 now, 1 1. So then this Y value will becomes what, 0. 0 will come here, then this value X value will becomes 1. So tell me now X value becoming 1 and Y value becoming 0. You see this thing in this case kya hone wala? So in this case what happens now, X value may be 0, Y value 1, X value 1, maybe Y value 0. So it is happens like this now. So yeah, so kaun sa option, tell me now here. We have a stable output we have, but lekin, so here X value 0 or Y value 0 we cannot say. That depends upon the delays. Here we have delays, they given unequal delays. So if it is stable case, we don't have any stable output. If we have a equal delays, there is no stable output. So then what happens now, Diwali aayega. In case of equal delays, we have Diwali chalega. So the Diwali, which we can call this as a critical race now. critical race चलेगा. Done. Now you see this problem. In the circuit shown the positive edge trigger they have used. The XR gate output is 3.3 volts for logic high. So they given this is 3.3 volts for logic high and 0 volts for the logic 0 levels. Okay. The data bit is and the clock periods are equal and the values of delta t by t clock is given as this much. Okay. Now where the parameter delta t and t clock are shown in the figure, assume that the flip-flop and XR gates are ideal. If the probability of the data input transition, which is given as 0.3, now they are asking to find the average value. This is also one good problem. So you see this thing here, they given that. They given the clock signal first of all. You see the clock signal, fine. And what else you see this thing here? This value which is given as like this. Here this is how much now? Delta t. This is how much you tell me now? Delta t. This is after. Right. We have like this. This is my data. Now this gap which is given as what to tell me now? Delta t. This is my d, isn't it? Fine. Now you see this thing. Let's see the expression now here. Now what we'll get now? Dn. So this is output. So you see this thing. Output of a d flip flop is same as the input. Hana boliye. So can you tell me the output? First of all, you tell me. Now here until this there is no clock signal. If there is no clock signal, output is 0. Here onwards from this here in this region, you can see my output which is equal to 1. You tell me. Output is 1. So this is a positive trigger now here. Right. Now you tell me this my output is 1. This will be continued until the next clock has to come. Isn't it? So up to here. Now the moment clock came, so then this value will be maintained now. This value which is equal to 1 only, isn't it? This value which is always 1 only. First we are doing the output of a D flip flop here. This thing we are seeing. After that X will come. X is equal to what now here? The D XR with Q. First we should get the Q we should get now. And this Q will get as like this now here always which is 1 only. Now we need to see this thing here, output now here X. X is nothing but what now here? XR between D and Q. Tell me now here what is this thing here? So whenever the different case or different input output is 1 now here. Here this is 1. In this region output is 1 यहाँ से यहाँ तक. Next in this interval, so this is output is 0, you see. This interval output is 0 in this interval. Now here onwards this output is again 1 up to here. Yes. Now you tell me now this is 1. Here onwards again the output is 0. Up to 1 clock pulse we need to see now carefully this value. Yes, this value 0. Up to 1 clock pulse means यहाँ से यहाँ तक हम देखना पड़ेगा. Up to 1 clock pulse. Isn't it? Now you can see now let us find the duty cycle here. So here how much this value here, and this is how much we can say now this is delta T. How much this value, which is the delta T. Now from here to here this is called as one time period now. This is called as a one time period, right? And one time period, right? All of you tell me this thing. And they given this thing here delta T by T clock, which is given something, you see carefully how much this value. They given this value 0.15. They given this value. So now I want to find the duty cycle here. Can you tell me the duty cycle here? How much we'll get? So duty cycle T on by T total now. We need to see the T on by T total. How much the T on and how much the T total? You see this thing carefully. Now you tell me now here this is what you tell me now here. यहाँ से यहाँ तक this period. कुछ so this thing Dean, yes. Initially the D value given us like this. Okay, here. Okay, this is up to here. Same thing we have drawn now. So this is delta T. Okay, here we have did a small thing we did here. Look at now here only we can draw. So to avoid the confusion here. So tell me the DN, you tell me here. DN is we have taken as this thing. You see this thing here. C is my DN. Here only we have taken DN. This is my input data. So tell me now, can you tell me now this green one is the input. So see this thing here, this green one is the input data. Okay. So now tell me what is the Q, you tell me output, which is same as input only. So when we have a clock is there, you would see this thing here, we have clock is there now. Before that there is no clock here, 0. In this interval clock is there, so output is 1 here. यहाँ से यहाँ तक. Now again this is another clock, until that it will be maintained this as 1. So at this location input is 0 now, tell me. Input is 0 when the clock is present, so then it will become 0. So this is the thing we did mistake earlier. Now here this value clock is there, output is 1. Here this is my output of a D flip flop. Thereafter we need to see this thing XR we should see. Now tell me now XR between what to what you see? D and Q. So tell me now here in this interval up to here this value 0, this is 1. So output the 1 hoga na here. So in this interval both are 1, so output will become 0. Right. Next here this is 1 and this is what you tell me now here 0. So then this value, so then this again this value will becomes 1 hoga now tell me. Now this is 0, this also 0. So output is 0 here. Next up to here, thereafter again this my output is 1. Isn't it? This is my X. Now here you see this thing here. How much this value? This is something delta t, isn't it? Now you can see now from here to here, this is a time period, right? This is the time period. So I can say this is the time period. Now tell me. Up to here, this is the time period. In this time period, you can see delta t is a, this is 0. So remaining time you see this thing, this value which we can say, this is nothing but t minus delta t. This is t minus delta t, isn't it? So from this I can get my duty cycle here. Duty cycle which is given as on time is t minus delta t by t. Yes, on by total time. So it will becomes what we can say 1 minus, I can say this as delta t by t, which will becomes what to tell me 1 minus delta t by t. So it is 0.15. So this value how much you tell me now here? 0.85. This thing. This is the duty cycle. If I know the duty cycle, so if I know the duty cycle, from this we can get the power. Average value we can get now. Average value. Tell me the average value which is given as V on into duty cycle plus what you tell me now V off into 1 minus duty cycle if we have probability into probability P. Now they given this on state value given as a 0.3, off state value given as a 0. So that means what I can say, tell me now here, V on value that is 0.3, sorry 3.3. No? So which value given as, what you tell me, 3.3 is on state value, and the duty cycle, no it is not a square. How it is a square we can say? You can't say this is a square now. 0.85. 0.85 plus what now this value 0 into D. P is a probability is how much? 0.3 given. So this is 0.3. So how much will get you tell me now here? 3.3 into 0.85 into 0.3. So tell me how much will get? 3.3 into 0.85 into 0.3, which is given as 0.8415. This is the average value. No, it is not a square wave. How it is a square wave? So in this delta t we cannot say in the t by 2. Who said it is a delta t is a t by 2? It can be any value in a random value. Output, final output only. It won't be square wave. Fine. Okay. Yeah, that's for the today's session, and we'll meet tomorrow. And tomorrow we will discuss the some more problems on the sequential part and the transients and AC circuits in the networks. Okay, and the day after tomorrow we'll do completely maths only. We'll do completely maths only. Fine. Okay. Yeah, that's for the today's session, and we'll meet in the tomorrow. Tomorrow same timings we have. Okay then, see you. Bye bye. Good night.